We are at quarter past the hour, so I'm going to go ahead and get started. We are recording this webinar, and all of you will get sent a recording of this in usually within a week following the workshop. So this webinar is going to be focused on guiding students to success with data, specifically when working on the IA for IB science. So presumably all of you are working in IB schools or working with IB students in some capacity, and that is going to be the lens that we are going to focus on. Of course, if you're not in an IB school or working with IB students, a lot of this information is just applicable for students and people learning to work with data in a variety of contexts, but we are going to have a focus on IB. I will be your host and your presenter today. My name is Aaron Reedy. I was formerly a high school biology teacher in the Chicago Public Schools, and I founded DataClassroom as a graduate student at the University of Virginia. We currently work with about 150 school districts around the country, as well as about 50 universities at this point with the university level version of our platform. As a scientist, I was an evolutionary ecologist. And then, like I said, I also have a background as a teacher, and it's really those experiences that led me to put a team together that would build what is now DataClassroom. So thanks for joining me today. Our outline for today and what we're going to cover, we're going to just talk briefly about data tasks for the IA. And as part of that, I would love for you to drop in the chat what is the thing that your students have difficulty with when working on the IA in terms of data. So what is the data task that your IB students find the most difficult when they're working on their IB? If you want to go ahead and drop that difficulty or that challenge into the chat, I would love to see that. Secondly, I want to just cover something that I call tidy data, and I did not coin the phrase. That phrase was coined by a very famous statistician named Hadley Wickham. But if you've been to DataClassroom webinars before, or if you've been to a PD session at your school that we've delivered, there's a really good chance we've talked about tidy data because we think that tidy data is really important to learners learning to work with data. And then finally, the third thing we're going to do is we're going to cover data concepts, and I've organized them from a document that's called Mathematics, a biology teacher support material, which is a general kind of guide for working with data that was put out by the IB folks. And we're going to cover things like mean and median. We're going to cover some different stats tests and things that are mentioned in that document are chi-square, regression, t-test, ANOVA. We're going to talk about strategies for talking about correlations. I find that this is an area that a lot of teachers find challenging, and students almost universally find challenging unless they've had direct instruction in it. But giving some language and some guidance for how to talk about correlations, and then error bars, and we'll show you how to do everything error bars in DataClassroom, as well as talk about some new error bar options that are specifically for IB physics that have been put in. And then I just want to put a word in that we've got some new IB physics specialty features coming out soon, and want to talk about that. So in the chat, looking at, I asked if anyone wouldn't mind sharing what are some data tasks that their IB students find difficult. And thank you, Kelly, for mentioning that your students haven't had statistics before, and now they're acting as student researchers, and they have no idea how to use statistics and how to interpret them. I have some strategies for that, and I will mention those explicitly as we go over that. And then I see graphing and statistical analysis. I see graphing. We're definitely going to cover some strategies for graphing and stats. And then Jake says, statistical tests as well as organizing their data for better analysis. And we're gonna definitely cover that organizing data in the tidy data section specifically. So with that, let's get to this outline. And the first thing that I want to cover here is, hold on, my slide is being delayed on the advance here. My Google Slides might just be running slowly as I've got Zoom running here. I might try. Give me 1 second. And we'll just go from here. So just wanted to kind of give an overview of some of these student data tasks that are in the IA, and the slide advance is not wanting to cooperate. So here, I got another idea. I'm just going to go back to the sheet, and we won't look at this in presenter view here and slideshow view, but we'll just look at it like this. I think you can see my screen here. But I think one of the reasons that the International Baccalaureate IA is such a difficult task for students is because it asks them to do just about everything in the research process from start to finish. So they have to do all sorts of data tasks. They have to design an experiment that is going to produce data that can test a hypothesis. That in itself is a pretty advanced data task. In addition to that, they're going to have to present their data with an appropriate graph. They are often expected to use statistics to analyze that or to bolster their conclusions. They're asked to interpret that and use nuance in that interpretation when they're sort of writing up their conclusion for that. They're going to have to get at some of the subtleties of interpretation. And then finally, overall, it's just a big, very thorough data communication task. So these students are really doing a lot of things. And I have to say that I don't think there's many places in our education system where students are asked to do all of that until they get to graduate school. I think even in the process of getting a college degree in the sciences, you might not be asked to do all of those things unless you're doing some independent research within a lab. But for the most part, there's not a lot in high school and secondary science where we ask students to do these things. So I really just want to kind of point out how much we're asking our IB students to do, and that it's not surprising if your students find it challenging. So with that, we'll go on to teaching students tidy data and sort of what are the basics of that. Now, if I was delivering longer form PD, if I was doing a half-day session at your school, we would spend at least the first hour and maybe even the first 2 hours working on some tidy data problems where we'd be taking untidy data sets and tidying them up. But I want to show you just kind of the basics of how to organize your data for better analysis. And I would show them this slide very early on in the year that they are going to engage in an IA project. This is sort of a picture of what tidy data is, and it breaks down the anatomy of what we're looking at here. And there are 3 key vocabulary terms that you want students to know. This is going to make sure you're all talking a common language when they're working on their IAs. It's going to facilitate their ability to communicate to you when they're having an issue, and it's going to help you to more rapidly understand what they're doing. This is the universal format for data in pretty much the scientific community, as well as engineering or even business. This is how professionals work with data. They most commonly we'll organize the data table where every column is a variable. So you see the vertical up and down arrows here. These are representing variables. And in our simple example here, we have country, year, cases, and population. We have 4 variables. So we have 4 columns. Each variable should be in one and only one column. And on the next slide, I'll show an example to kind of reinforce that. Second vocabulary term is observations. And every time we are recording data, we're making an observation and we're adding another row to the data set. And so you can see this data set has 6 rows, so it has 6 observations. We have 2 observations for Afghanistan, 2 observations for Brazil, 2 observations for China. And so each one has a row in the data set. Data sets get longer in tidy data. So once you have set up your experiment and you've determined what you're measuring, that determines how many variables you have and how many columns you have. But as you replicate and you collect more observations, that's going to make your data set get longer. Sometimes tidy data is called long form or tabular format. So we got variables, we got observations. And finally, the third vocabulary term is values. Now, these are the cells, right? These are the individual pieces of data that go into the data table or the data set. Each variable has a value for a specific observation. So, for example, in row 1, we see that we have the first observation. The variable country has a value called Afghanistan for that variable. And then we see numbers for years, cases, populations. Now, it's very normal for students to think of numbers as values. That's what they've been getting in their math classes probably since 3rd grade. But when we have a categorical variable like country, it might not be as obvious to think of things like Afghanistan or Brazil or China as values, but those are values of a categorical variable. So when we're talking about a value, it could be a value of a categorical variable, or it could be a value of a numeric variables. But these terms are important. They kind of anchor us: variables, observations, and values. And yes, I will be going through some samples on the website with different data sets. Pretty much after we get through tidy data, we're going to jump in and look at actual data set examples. Just responding to a question there in the chat. So this slide here, want to just show you the top is untidy data, and you can see there's 3 columns there. One column called day, one column called plant A, and one column called plant B. And the reason that is not tidy is because in the plant A column and the plant B column, we're actually mixing information or values about 2 different variables. We have the 2 variables here we have whatever these values are, these numbers, these like 2.1, 2.4, 2.63. And then we also have which plant is it, right? Plant identity or plant treatment or something. And so we have these 2 variables, but we've smushed them into the same column, and then we've repeated that and done it again. And if you look at the tidy example, where we have one variable called day, we have one variable called plant, and the values of that variable are either plant A or plant B. And you can see those values repeated in the different observations. And then we have this other variable called height, which in the first example, the untidy data, wasn't even named. And so we have height in centimeters, and now we can see that that's what those numeric values are actually values of that variable called height. And so we can see the data set is now twice as long in terms of number of rows. It's 10 rows instead of 5, but each column actually corresponds to a variable. And so later on, when we are thinking about things like what is our independent variable and what is our dependent variable for a different question, we can answer those by pointing to a specific column in the data set. And so that is the tidy format. Okay, so now we've got tidy data, we've got the basics under our belt. I want to look at some different data set examples that will illustrate these concepts. So concepts like mean and median, change over time data, stats tests, talking about correlations, error bars. And again, I pulled a lot of this stuff from this IB document that was this biology teacher support material, but I think it's good general material that applies even if you're teaching a course other than biology. A lot of this still applies. So let's go ahead and look at an example that we're gonna illustrate multiple things here. We're gonna illustrate mean, median, stats tests, error bars, and this we're gonna use some real IB data that was collected by a student who asked us some questions about this. And their hypothesis, they wanted to test the hypothesis that a dog's mouth is just as clean as a human's mouth. Let me correct my typo there while I'm at it too. So testing the hypothesis that a dog's mouth is just as clean as a human. So let's take a look at the data first. And I'm going to actually start at the beginning and show you how to upload this data into DataClassroom so you can picture if you were using students' data, how you would get it in here. So this is the DataClassroom dashboard. And if you see this stack of green buttons on the left, you'll see that there's a button that says import data. And you have this button whether you are a student or a teacher, both versions of the tool, which are very, very similar to one another. They both have this button that's called import data. And when you click that, it will ask you, where are you bringing the data in from? Are you fetching it from a file in Google Drive? Are you uploading it from a file that's on your computer already? Are you pasting data in? And that's what I'm going to use, and I'll show you that in a second. Or you can create a blank data table. So I'm going to go over to some data that I actually have in a Google Sheet. And so you can see this Google Sheet here. And what this student did is they measured data from 25 dogs and 25 humans. They took a little swab from inside the mouth, and then they measured the absorbent. They they cultured that swab on a plate then, and then they transmitted light through that and got an absorbance value. The higher the absorbance value, that translates to greater bacterial growth on the plate. So that's just a little bit about what this student's IA project was. And I am going to just go ahead and copy these data here. So you could just see I dragged my cursor over that and I copied that. I'm going to go back to DataClassroom at the data import. And I'm going to put my cursor here where it says paste copied cells here. And I'm going to paste those cells in. And you can see the data set is in. And I'm going to call this human versus dog mouth. And that's the name of my data set. And I have the data in, and I'm starting to work with it now. You'll also notice there's a flow chart at the top here, kind of upper right, that says preparation, visualization, and statistics. This is guiding students through the workflow of working with their own data. And going down to prepare, I'm going to click prepare. It's asking me to do two things. One, it wants me to put some description or kind of metadata about this file. So when I open this up in the future, I know what this file is. That is a very good data practice to teach students to do and get them in the habit of doing. And then I need to choose a variable type for each of my columns. And I can click this learn more to learn about what are the different types of data that DataClassroom recognizes. I'm going to say most of the time it's either numeric or categorical. And then sometimes you'll want these identifiers as well. And we're going to get to see all three of those types here. So I'll say I'll fix this. And then I'm directed to where these little caution triangles are. And you can see there's a type here. When I click this, I get the drop down, and this is species, and I can see I have values. My values in this column are either dog or human. These are categories. So this is categorical data. And then, once I do that, I get these, I can change the settings for values if I want to use different colors to represent human or dog or things like that. But I've done that. Absorbance value in, I believe it's nanometers here is the unit. And I'm going to click, this is numeric, because these are all different numbers. You can see these are things we measured. And then test subject ID, these are identifiers, and they're not something that we're going to analyze graphically, but they're in there, and so I've coded those as identifiers. And then up here is where you can see it says a short description can go here. This is like the box on the upper left. And I'm going to put, I'm just going to call this IA example data for the webinar on 9/23/25. So if I come back to this file, and I'll share this file with you in the follow-up material from this. So if you want to come back and play with this, you can. Here, now I'm going to go and graph these data. So I could continue on with the flow chart, but I want to go a little bit more free form. So I'm going to go up here to the white bar, and I'm going to click the graph tab there, and I'm going to jump over. If I want to start looking at data, like if I want to look at, all of the absorbance values that I got, I can see them here. The control panel at the right is going to start giving me options as they might become relevant. So, I could look at these data as a histogram. I'm going to stick with looking at them as dots. I could play with the jitter. This is the horizontal spread of the points. I'll stick with 2 units of jitter. I'm going to add descriptive statistics here. And so now I'm looking at the mean and standard deviation. If I check this box right here that says values, I can see that, the mean absorbance value is 7.8 here. And I'm looking at this to kind of dive into the student's research question. Remember, their hypothesis was that the dog's mouth is just as clean as the human's mouth, and they were measuring that by culturing these bacteria. And if I split that up, added the variable species there, and now we can see we're comparing these, and the mean absorbance in the dog for the dog samples was 8.06, and the mean for the humans was 7.588. So this is, maybe not any support for the student's hypothesis, but this is looking like maybe a slight difference with the dog mouth actually having a little bit more bacteria, which would not support that student's original hypothesis. Now, you could probably do okay on the IA if you stopped here with your analysis and you drew some conclusions, you reported your mean and standard deviation, or maybe your mean and 95% confidence interval like we're looking at now. I changed from standard deviation to 95% confidence intervals, and those error bars are a bit smaller, and they're just barely overlapping here. But if we really want to know if they're significantly different, we have to go over and actually run the test here. So with error bars with 95% confidence intervals, if they are completely non-overlapping, it definitely means they are statistically significant at the 0.05 level. However, if they're slightly overlapping, you can't actually tell. They may or may not be, and they're pretty close to some value that's 0.05. And so this button over here, this is the graph-driven hypothesis test. It's taking a look at the data that the students have on the graph, and it's kind of almost like a digital assistant here, because if I was the student's teacher, I could look at these data and I could say, this is definitely a situation where you'd want to apply a t-test or possibly a non-parametric version of a t-test. But you have 2 groups, and you're basically asking the question, is the average value of these 2 groups of numbers different from one another? And, is it significantly different? And so to ask that question, I launch this graph driven test, and it's saying, yeah, this is a t-test in this situation. We're assuming normally distributed data. We have two categories, and we're comparing one numeric variable. That's absorbance value in this case. And when I click calculate, I'll do that in a second, but I also want to point out here, I can get more advanced options with this little toggle switch on the top. And when I turn that on, I have more options for statistical tests, and I can choose to do a non-parametric test. So if I decide that, those data are not close enough to normality, I can use this Mann-Whitney U test. But I'll say in this case, you're going to get about the same answer either way. And with a lot of data sets, that is the case. But so I'm just going to do the t-test. I'm going to click calculate, and the student gets a little pop-up at this time explaining when should you use a t-test. And this is really helpful. This is the kind of thing they would want to include in their results or statistical methods section, where they would say, I chose to do a t-test because this is a test that is appropriate when testing for a difference in the average value of a numeric variable between two different groups. They could put that into their own words. There's other ways they could say that, but fundamentally, they want to justify why they chose that stats test for this situation. And it's the reason is because they were testing for a difference in a group of numbers, which was absorbance value, and they had exactly two categories, which were dog and human. So that's the reason why a t-test fits. And they can click calculate here, and they can see it's going to give them here, they get a p-value of 0.05, which means there is about a 5% chance of getting a difference in that average value, like we see here, about a 5% chance of getting that due to random chance alone. And so in the scientific community, anything at 0.5 or below, we say is statistically significant. But I'm going to click this little explainer because I think this will help explain to students that science and statistics can't give us a yes or no answer to a question. They really just give us confidence in a conclusion. And with this, we have some confidence that the groups are different because we only have about a 5% chance of getting data like these at random. So we conclude this is support for the hypothesis that dogs and humans don't have the same amount of bacteria in their mouths, which as you know, the kids' hypothesis was that the dog is just as clean as the human. So this difference is actually looking like, evidence that's not supporting that maybe they are different, and maybe the dog's mouth does have more bacteria than the human mouth. So this is all to help students, put those results in context. So we covered, many things that IB is looking for. We did mean. I didn't actually show median, but I can do that by changing what kind of display that I'm putting, beside the dots. So if I go down and click median based, now we're looking at a box and whiskers plot with the median highlighted. And I also want to point out, I don't have to show the raw data. I do think it helps students to talk about their data, to look at that raw data. But if you want to hide the dots, we could do an alternative presentation of that data where, we're just looking at the box plots that show us the interquartile and the median. I do tend to be, kind of fond about the showing the dots, and the research into how students learn about data interpretation tells us that they do better when they can actually see raw data like these. So that's, one argument why you might at least coach your students to look at the data in this way, even if they choose a different presentation of it in their final project. But I think, this graph that we've made here, this would be good in an IA. And they could go up here in this camera that's in the upper right portion of the graph. They could copy that graph to their clipboard, click copy and done, and now they're ready to paste it into whatever document they're using to write their IA up. And so again, that's pretty much taking us through the first example. We'll go through another example here in just a minute. But if anyone has any questions, feel free to drop those into the chat. And we're going to take a look at another example, and let me just set this up with a slide. And this next example, I want to show you how a student could present classic change over time data that has multiple groups. I see this kind of data in IAs all the time. And this example is they're doing a classic fermentation experiment where they're using different sugars, and they're adding yeast and starting fermentation, and then they're measuring carbon dioxide as a response variable to make a graph like what you see here. And let's go through. And this time we can start from the moment we have the data. And I saved these data. So again, I'll share this data set with you. But I'm going to go up to data sets in my stuff, and I'm going to search for fermentation, and I'm looking for this data set. This is one that I own. This is not in the library, but again, I'll share this material with you. But this is classic fermentation experiment with different sugars. And we can take a look at the data in tidy format. We have one variable here called sugar, which is all the different sugars. We have another variable called type, which has binned the sugars into either no sugar, like we see in the control, or disaccharide sugars, or monosaccharide sugar as well. So that's another way we can look at the data, and we see time in minutes, and then we see this carbon dioxide measure, and then we also had tube ID number as an identifier here. And yes, Michael, I will definitely share this as an example data set in the follow-up materials that I'll send out within a week of the webinar. But let's take a look at how students would graph these data. And this will also give you a little window into why tidy data is so powerful with computers, and how it really is a flexible format. So I'm going to add carbon dioxide. This was our response variable, and let me show all of the data points, and I've displayed it with the mean and standard deviation. I'm going to actually make that go away. That's not so interesting, but we're just looking at the data that we have. And then on the x-axis, I'm going to place time here. And I've also, sorry, in default version, it would just come up like this. You wouldn't see that regression line right away. And you can see what is on X is in red, and what is on Y is in red to the right of the graph, the little red X and Y. I can flip that if I wanted to. But of course, it's more conventional to put time on the X-axis. So I'm going to flip that back. And now we're looking at these data. We can see a pattern where, it looks like we've got, remember we had different sugars, and you can almost see where we've got the different sugars falling out in different places there. But I'm going to go up to this variable called sugar, and I'm going to add this on here, and I'm going to add sugar as Z, and Z is this variable that's defining our legend here. And so now we can see a different color for each of the different sugars. And some of these patterns arrive, right away, where we can see, like, down here, we've got our negative control down at the bottom. Here we've got this positive control. Here we've got lactose. Here we've got maltose. Here we've got glucose, and here we've got fructose. I'm gonna actually do a couple of things here where I'm going to add descriptive stats on top of here. And I'm also going to hide the dots. So you can see over here, there's this drop-down menu, show dots. I'm going to hide dots. And I'm looking at this. So now I'm looking at the mean and standard deviation that for each sugar at each of the different time periods. So DataClassroom is recognizing that all of these values of X were falling along discrete points, the 0 minutes, the 2 minutes, the 4 minutes, the 6 minutes, and so on. And so it's organized those and giving you the summaries in here. I can check this little values box. So I can see, the mean. It's quite a large there, but I can get, the mean and standard deviation at each of those time points for each of those sugars. I'm going to uncheck that values box just to make that go away for now. There's also some other things I can do here. If I wanted to get, you know, maybe a little bit more serious with stats, I could apply regression lines for each of these different sugars. But I'm going to show that to you for a second. But I actually don't think that's what you want to do, right? So I could do that. I could do a two-way ANOVA, and the software will guide you there to do a stats test that would let you know that those different sugars have different intercepts and they have different slopes. But that's all kind of obvious. So this example is really one where I think you might not use stats, but you might go with this little option to join all of the means and just kind of go with a pretty simple, just showing a different line for each of the sugars. And then, you draw your conclusions where you talk about, you've got this group of three sugars that all seem to have a higher rate of fermentation, and you had these two sugars that had a lower rate of fermentation, and then you had your negative control, which is way down, in the lowest values. So this is an example where you could get it, you could launch stats and do that two-way ANOVA. But this, here I do have to go into the advanced options to do the ANCOVA, not a two-way ANOVA, but an analysis of covariance, where I apologize for saying two-way ANOVA, but this covariance is sort of looking at the covariate, which in this case is the sugar. And so, when I run this, it's going to give me a statistical effect for the sugar itself, a statistical effect of time, and then a statistical effect of the interaction, which basically saying that the relationship between time and carbon dioxide rate is different for all of the different sugars. It depends on sugar. But again, I don't actually think that is the thing I would do in this case. I would probably stick with the more simple analysis like this, where I'm doing kind of a line graph just sort of as a visual aid, so you can see that there are different curves there, for different sugars. So that's one other kind of example. And then the last and kind of, I think the final thing that we're going to have time for today is I want to talk about teaching students to talk about correlations. This is something that I see students mess up in IAs all the time, and something that I've seen teachers struggle with as well, to sort of find precise vocabulary to talk about these correlations. And so I think that we can use some kind of descriptive words to talk about correlations. So we can think about things as either being on the one end of the spectrum, a perfect correlation. The X variable explains the Y variable 100%. We could talk about no correlation at all. The X variable doesn't explain the Y variable in any way. But then we could talk about the things in the middle as either being strong, moderate, or weak. And I think there's a parameter of a regression that is really helpful for students to zoom or to kind of hone in on when they talk about these things. And that parameter is R squared. So there's a correlation coefficient R, which varies from 0 to 1, but then you can square that, and that's where we get this R squared. And it also varies from 0 to 1. But the R squared, I think, has the advantage over just the plain R, that the R squared value translates to the percent of variation in Y that is explained by X. So if you look over here on the right, you can look at these R squared values, and you can see that the two panels, the leftmost panels, there's an example of a weak positive correlation and a weak negative correlation that have an R squared value of 0.04. So about 4% of the variance in Y is explained by X. And then we have a moderate correlation, and you can see both a moderate positive and a moderate negative with an R squared value of 0.36. And you can see where that translates onto the table that I took from the IB materials, where they define moderate correlations as anything with an R squared of between 0.3 and 0.49. So that's an example of a moderate positive. And then you can see strong correlations have R squareds between 0.5 and 1.0. And you can see here, this is what an R squared of 0.81 looks like, both in the positive direction and the negative direction. So I think this slide can be very useful in teaching kids to talk about correlations. And if we go over to the Data Classroom resource library, I want to show you a data set that you can use to illustrate some of these real world correlations, a strong or a weak, a moderate, and a strong. And I'm going to pull up this data set called Life on the Edge, Biodiversity of Coastal Habitats in Nova Scotia. So this is looking at measures of biodiversity in a simple experiment comparing sheltered and exposed habitats in Nova Scotia. And just to look at these graphically, if I take a variable like total species, which is one way that you could measure biodiversity, and I look at its correlation with abundance, and I'm going to add a line of best fit, a regression line, and we can see this is an R squared value of 0.324, and you can see that in the parameters under the equation that pop out when I add the regression line. This is a good example of a moderate correlation, right? But I'm gonna add some other variables. So I've added species richness and evenness. And if I switch, what is my X variable? I'm going to keep total species on Y. And now, for example, I'll look at species richness. Well, this has an R squared of 0.782. And this is a good example of what a strong correlation looks like in real life. And again, this isn't as strong as you might get in, like, say, a standards curve in chemistry, or maybe an experiment in physics. You tend to get very strong correlations in those cases, but this is still a good example of a strong correlation at 0.78. And then I'm going to switch again. So instead of species richness on X, I'm going to put evenness on X. And here, we get an R squared value of 0.00113. So this is far less than 1% of Y is explained by X. This is a weak correlation in the real world. I also just want to point out that the R squared value and the strength of the correlation has nothing to do with the slope. It is possible to get a steep slope and a weak correlation, or vice versa. They're not tied. They're actually measuring separate things. The slope is really just saying, for every unit in X, what is the predicted value in Y? But it's not the same thing as explaining, how tight are the points to the line, and that's really what the strength of the correlation is showing. We are just about out of time, so I want to put up this contact information. If you have any questions about using the Data Classroom tools, feel free to reach out to me or the team. My email is aaron@dataclassroom.com, and the general info@dataclassroom.com is monitored during the workday at all times. So that is always the fastest way to get a response. And question in the chat: are the resources specific to help new teachers to DC, yes, there are. We have our structured learning checklist, and I'm going to make a note to include those in the follow-up to the webinar. So I'll give you where to find the learning checklist. There's also a tutorial lesson that's meant to be like an introduction to the tool. And we both have one of those at a level with statistics and one at a level without. I'll include both of those. And then I'll also introduce you to our user guide, which is searchable. So if you have a specific question at the moment you have it, you can search it in the user guide, and that can be also very helpful as you're learning. So again, thanks for the kind words in the chat. I'm glad many of you found this helpful, and thanks for joining me this afternoon. We will send out this recording. Please feel free to share it with any colleagues. And if you have, again, any information about Data Classroom that you'd like, feel free to reach out. If your school needs a price quote, that info@dataclassroom.com is the right email for that. So thanks for joining me.